Hello and welcome to another episode of me looking at websites of different companies from the quantum technology space. As per usual, get yourself something to drink, always stay hydrated, and let's take a look at this website which says OQC up here, so OQC.tech. What do we see when we start the website? So first of all, we have this very nice animation here of a shiny chip, and it says application optimized quantum compute, building a quantum enabled future. So right here we see quantum computing is poised to reshape our world by addressing the complex challenges we face today. We deliver logical era quantum solutions that will empower humanity with quantum capabilities and unlock commercial advantage. So this is all about commercial advantage here. It says it's more than just a computer. It's going to revolutionize computing, hybrid computation, and limitless potential. So again, it looks like what we are seeing here with OQC is a company that is providing quantum computers, so hardware. We also see here quantum computers are a new generation of problem-solving machines. They operate according to completely new rules. Probably they're referring to the rules of quantum mechanics. And indeed, a quantum computer is similar to like what you have with your graphical processing unit. It is a system which is optimized to solve specific problems. So it's not going to be used to solve all of the computation problems. There will always be systems that are more efficient in specific things, but the quantum processors, they are potentially, we don't even know because we don't have them yet, but potentially they can solve problems more efficient than what we have today. So that's why also some companies call it QPUs, or quantum processing units, similar to the GPU and the CPU. Then we have hybrid computation again, which refers to a combination of a quantum computer and a classical computer, usually like a supercomputer, working together to solve a specific problem. And then we see here limitless potential. Quantum technology will open the door to innovation, creating new products and new opportunities. Then here we can see probably what the system of OQC looks like. So we see here again this typical cryostat with the hanging type of cylinder. On the right side we see something that looks like a classical supercomputer. So we see a lot of cables here which go up to the cryostat, which is probably the control units for the qubits. And then on the left side, I think what we are seeing here is basically the cryo control unit. So you see here something that looks like a cryogenic trap. So basically to trap gas particles inside the system, inside the vacuum, to keep the system clean. Then on the left and on the right, we see some open systems. So we can see that we have these different stages, which looks like a chandelier. So basically we will have in here a solid state quantum computing system, so not an ion trap, but something like a superconducting or spin qubit system. Probably we will learn more about it in a second. So then it says, tackling our most pressing challenges lies in empowering humanity with quantum capabilities. Accessible, secure, reliable, reproducible, and resilient. Okay. Then we see the partners here. So there are some big names already on there. Just to name two, we have NVIDIA and Riverlane. There's a video down here. I will not click on this for now. And then we see this need help and the blogosphere. Okay. We can already see here in solutions, these are the solutions that are being targeted. So we see financial services, automotive and logistics, energy and climate, health and life sciences, and national security and defense, which I would say are the ones that are being targeted by quite a lot of companies right now. We will see in a second what they are actually referring to. But first of all, let's take a look into the tech, because I'm a quantum scientist. I love to see how things are actually being built here and what technology comes into play. So what do we see? we see that, okay, we have some high frequency lines here that looks like radio frequency lines. Then potentially some filters here, could be like a metal powder filter type of thing. I'm not sure. Then it says we are mastering, integrating, and scaling quantum computing across the entire system stack from the core quantum processing unit, QPU, that's what we talked about before, to the compiler. So basically what takes the program, the algorithm that you came up with, and compiles it such that it can be executed on the chip. We ensure robust connectivity through enterprise-grade networking to deliver the simple, clean quantum technology to the market. Okay, so then we see again here low crosstalk, enterprise-ready quantum systems, simple quantum architecture, and modular design. Then we see here the OQC Toshiko. Toshiko is our second generation quantum computer with 32 qubits. Okay, so that's like the probably the entrance model, like the entrance one that you can buy. So you see again here the picture of the Kreisstadt. Then we see Lucy. Lucy was our first generation 8-qubit processor and the world's first quantum computer as a service, QCAS, in Europe. So it's a European company. She has been reliably serving customers for more than 2 years with both public and private cloud with an uptime of over 98%. Okay, so that was the first product, I guess. And wow, that's an astonishing number, 98%. So that basically means that, what was it, 2 years? So out of 2 years, you can do the math better than I, but 2%, that's just a couple of days of off time. So especially taking into account that we have like Kreisstadts and all this electronics and stuff, this is pretty remarkable. From my lab times, I can tell you the uptime of the Kreisstadts that I was operating was not 98%. And I tried my best. I really tried my best. So what do we have here? The coax mon. So also something interesting is you have like the all types of mons, X mons, trans mons, whatever. Oftentimes that refers to superconducting qubits. What do we see here? Our core technology, the coax-mon, has a three-dimensional architecture that brings key componentry off-chip. Okay. Do we learn anything about how it actually works? I don't think so. Then we see here the newsroom, which is pretty up to date. So I'm recording this end of May. We see here like 19th of May, Q control, 19th of May news. So that's pretty decent. That's pretty new. Let's see if there's also something about there is something about the coax-mon. Let me quickly go in there because I would really like to know how it actually works. So, okay, there's a video. There's a picture as well. So our coax-mon is a unique achievement in the world of quantum computers. Traditional 2D circuits require increasingly intricate engineering. Okay, so that's the coax-mon has a three-dimensional architecture that brings off-chip. Okay. Our chip and surrounding design choices have manifested in quantum systems. Okay, but I still don't really understand how it works. Let's see here. Okay, so we see that there is like different dots and then it's being scaled up, so they're connected. Okay, interesting. But not really sure, like from what I see here. Let's see if this explains something here. Okay, so there's like coaxial wires that are being hooked up to the chip, as it looks. It says 3D control. Okay, high coherence, that's usually good. Low crosstalk is also very good. I mean, that means the qubits are not talking when they're not supposed to talk, but not completely. I don't know actually right now how it works. I mean, please guys, if you or girls, if you know how it works, tell me down below in the comments. I will take a look at this side here. Yeah, there it says some performance numbers. So we have here the T1 and the T2 time, the fidelity. So that's all very good looking numbers. They have 32 qubits in a system that's running since 2023. Okay, so that all looks very interesting. Good. Then let's quickly take a look at the developer tools as well to learn a little bit about that. So as we saw before, they're not only building the quantum systems, which includes the crystal and the chip and all the like peripherals like lines, radio frequency and so on. They're also working on the software side, so the compiler, for example. Now we take a quick look at that. So we see that there is like a quantum assembly toolkit, the OQC quantum software as a service client, the QAT installer, and the CUDA quantum. So CUDA is from NVIDIA CUDA, I guess. Let's see what we have here. So here it says many options for you to manage both your access to OQC's quantum offerings and the tasks submitted to your system. So this is like the scheduling tool maybe. Then we have the quantum assembly toolkit, which is the low-level quantum compiler. That's the compiler that we talked about before, which is also in here is QASM, OpenPlus, QIR. Okay. Then we have the quantum assembly toolkit, which is apparently a Python package which can be installed by PyPy. That's very good. And yeah, then we have CUDA down here. And there's a repository. Again, we have the solutions that they are targeting. So very similar to what we've seen with others as well. We have quantum factorization. This is a security topic. So that boils down to the Shor's algorithm, which is a prime factorization algorithm. Prime factorization is a major topic in cryptography because it's being used to encrypt our messages, our end-to-end messages, because the prime factorization is an asymmetric problem, which right now can only be solved, like if you have a big number, it takes a lot of time to find both of the prime factors. Then we have quantum optimization. So this is typical optimization problems. We have quantum simulation, which probably refers to simulating the quantum nature of materials, molecules. So this is again like pharma, material design, things like this. And then we have quantum machine learning, which is this new category of algorithms which are using quantum computers and combine them with the idea of machine learning. So like models, graphs, which are being executed, trained with a combination of quantum and classical compute systems. Yeah, and then here we see again the different areas and industry verticals, and we also see some customers here. So NVIDIA is a customer, we see governmental customers, we see Riverlane again, the GESDA, which I think is leading into the Open Quantum Institute. So there's a lot of like known labels in here. Then there is some access topics here. So how can you get access to a system, I assume. And yeah, you have the typical things like you have an on-prem solution where you buy the whole thing, but you can also probably do something here with the plans where you can get some time to run stuff on a specific system or like via the cloud interface. Yeah. Okay, so besides that, there is a blog, there is some research. So they are also actively participating in research, as it seems. That's very cool as well. We always love it when companies are also publishing what they're actually doing and how it actually how the workings of all of this are. Yeah, here we can see Josephson junction effects. So Josephson junctions are usually like superconductive junctions that you, for example, need to also build like a transmon, superconductive qubits. Okay, so looks like we are talking about superconductive systems here. So my first guess was not too bad, I guess. Then there's finally something here about the company. Let's also quickly take a look at that. So what is the mission? The mission is to take quantum out of the lab and into the hands of humanity. So this is again like a statement of serving humanity with these new types of computers and solving problems like, for example, here climate we see and drug discovery. So really like things that are at the heart of today's society. Okay, they have an office in the UK, headquarter in UK, and an office in Japan, so already quite international. We see something about the fundraising here. So it says in 2022, OQC achieved 48 million Series A. That's pretty impressive. It's a lot of money. But also these things are quite expensive. Hiring good people is not easy. There are not so many people out there. We want to change that with the School of Quantum. We want to help educate people around quantum and make it accessible and democratize it. Then there are some awards. And I think with that, we have a first impression what OQC is doing. I hope you liked that video. If you did, then make sure to subscribe to this YouTube channel. I'll be out. As always, make sure you stay hydrated and see you in the next one. Bye bye.